Okay, so this question asks us to sketch the graph of the function f of x is equal to 2 into x squared minus 9 divided by x squared minus 4. So the first thing we would look for is the intercepts of the function. As you know, the y-intercept can be found out by putting the value of x to be 0. So substituting x to be 0, we would get f of x to be 0 minus 9, 2 into minus 9 would be minus 18 by minus 4. That would give us minus of, say, plus of 9 by 2. So the y-intercept would be 0 comma 9 by 2. The x-intercept can be found out by substituting the value of f of x, that is nothing but y to be 0. So if we substitute y to be 0, we'll get x squared minus 9 to be 0, x equal to plus or minus 3. So minus 3 comma 0 and 3 comma 0 will be the two x-intercepts of the function. The second thing we would look for is the asymptotes of the function. The asymptotes of the function, there are two types of asymptotes. One would be the horizontal asymptote. The horizontal asymptote can be calculated by using the formula limit x tends to infinity f of x. So that would be limit x tends to infinity 2 of x squared minus 9 by x squared minus 4. So substituting, we would get the answer of, so this would be limit x tends to infinity 2x squared minus 18 by x squared minus 4. So taking x squared common from this, minus 18 by x squared and x squared, 1 minus 4 by x squared. X squared would cancel, and as x approaches infinity, 1 by x squared will approach 0. So the answer would be, this term will go to 0 and this term will go to 0 as well. So it would be 2 by 1, just 2. So y equal to 2 will be a horizontal asymptote. Next thing we would look for is vertical asymptote. The vertical asymptote can be found out by substituting the value of x squared minus 4, that is the denominator, to be 0. This would give us x is equal to plus or minus 2. Substituting x is equal to 2 in the numerator, we will get a numerator will not be equal to 0, and by putting x equal to minus 2, numerator will not be equal to 0. So x equal to plus or minus 2 will be a vertical asymptote, because if it is 0, it would be 0 by 0, and that will not give us a vertical asymptote. So x equal to minus 2 and x equal to 2 are the vertical asymptotes of this function. The next thing we would look for is to find the points of maxima and minima. So for that, we would need to differentiate this function. So f dash of x would be, differentiation would give us, using the product rule, will give us this, and x squared minus 4, and the differentiation of the numerator to x squared would be 4x, and this would be minus of 2 into x squared minus 9 into 2x. So this would give us 4x cubed minus 16x minus 2x, 4x minus 4x q, and this would give us my 4 and minus 4 into minus 9 will give us plus 36x by x square minus 4 whole square. So this would be 20x divided by x square minus 4 the whole square. Okay. So we found the f dash of x. We found f dash of x. So substituting the value of f dash of x to be 0, we would get, so f dash of x is 20x by x square minus 4 the whole square. So substituting this to be 0, we'll get, so the sign would be like we put a value between 0 and minus to say minus 1. So this would give us 20 in minus and minus, and as it is a square, so it will always be positive. So this will give us a value less than 0. If you put a value 1, you would get a value greater than 0. If you get 2, you get a value greater than 0. If you put minus 3, you get a value less than 0. Right? So we get the values in which f of x is increasing. Now we will calculate the value of f double dash of x. So f double dash of x will be differentiation of the first one. So f dash of 20x by x square minus 1 whole square. F dash of this. So differentiation of x square minus 4 whole cube, x square minus 4 whole square, 20 minus 20x into 2 into x square minus 4 into 2x by chain rule. Yep. So this would be, we could take 20 into x square minus 4 common, and this would give us x square minus 4 here, and 2x, so 2x square here, right? 2x square and sorry, this would be 2x into by x square minus 4 whole power 4, sorry. So this would be minus of 20 3x plus 4 divided by x square minus 4 the whole cube. So this would be the value of f double dash of x. So f double dash of x is 0 at is never 0. F double dash of x will never be 0, and f double, because it's 3x square plus 4, 3x square plus 4 will have a minimum value at a minimum value of 4, because x square can never be negative. The minimum value x square can take is 0, and f double dash of x does not exist at x equal to plus or minus 2. So we would again check plus or minus 2 minus 2 2. Okay, sign of f double dash of x. Now if we put a value of say x from say we put a value of x to be 0, so this would be negative, this would be positive, and negative negative would give us a positive number. Say we put a value of 3, this would give us 3 square minus 4 positive, so this would give us negative. We put a value of minus 3, this would give us minus, and this would give us minus as well. So minus minus, so this would give us positive, right? Minus infinity, sorry. We put a value of minus 3, we get 9 minus 4 positive here and negative here, so this would be negative, sorry for that, right? So we know the value in which, so this is concave downwards, concave upwards, concave downwards, so we know the interval in which the function is concave downwards, the function is concave upwards. So let's plot the graph of the function. So let's plot the intercepts first. If you remember, we got the intercepts of x is equal to 0, 9 by 2, I guess, yeah, 0, 9 by 2 is the y-intercept, and x-intercept at minus 2, 0 and 0, 3. So the function will pass through these points, 3, 0. Next, we have an horizontal asymptote at y equal to 2. So let's draw 2, and it would have a horizontal line here, a dotted line at 2, and vertical asymptotes we found out at x is equal to plus or minus 2. So we draw vertical lines at x is equal to 2 and x is equal to, sorry, this is 3 and this is minus 3, sorry for that, 3, this is 2 and this is minus 2. So, okay, so we know the function has an asymptote at x is equal, has an horizontal asymptote at y is equal to 2. So the function would have tend to 2 from this side. No, as so let's look from minus 2 to 0. From minus 2 to 0 and 0 to 2. So from minus 2 to 0, the function is from minus 2, you can see that the function is from minus 2 to 0, the function is decreasing, and from 0 to 2, the function is increasing. So from minus 2 to 0, it's decreasing, and 0 to 2, it's increasing. And also we know that from minus 2 to 0, it's always concave upwards. From minus 2 to 0 is concave upward, and from 0 to 2 it's concave upward as well. So the graph would look something like this. Now, what about the x equal to minus 2, the left side of x is equal to minus 2? We can see from this that from minus infinity to minus 2, the function is decreasing. So and from minus infinity to minus 2, the function is concave downwards. So this would look something like this. And from 2 to infinity, it is increasing, and from 2 to infinity, it's concave downwards. So the graph would be something like this, increasing, concave downwards. So this would be the graph of the function 2 into x square minus 9 by x square by minus 4.